Good morning, Miss Fatten.
Morning, Miss.
Good morning.
Good morning, teacher.
Good morning, Zahra.
Good morning, teacher.
Good morning. Are you ready to go back to school?
Yes.
What about the others? Qarauna, you need to connect the audio, miss.
Yes.
Did anyone try to don't send me anything in the chat? Did anyone try to solve the worksheet? No one? Yeah, it's okay. We're gonna do it together.
Teacher, today I will solve it.
Now we're gonna solve it together. Since we're not too many, you can unmute yourselves. Unmute yourselves.
Yes.
If you didn't, this means that you're not here. Yusuf, Mustafa, Zahra. We're only 7 here, so you can unmute yourself and help me to solve the worksheet. Okay. If you turn off one light bulb, so you have a circuit, and you turned off one light bulb, all the light bulbs in the room go off. This means that all the appliances, all the light bulbs are connected to a series circuit or to a parallel circuit.
A series.
Why? Why do you think that they are connected to a series circuit?
Parallel. It's a parallel.
Okay, let's think again, okay? We have many light bulbs connected to each other. If we take off one, if we turn off one of them, all the others turn off too.
Series.
This happens in which kind of series? In which kinds of circuits? Series or parallel?
Series.
Series.
In a series circuit, good job. In a series circuit, if you disconnect, if you remove, if one of the devices or the bulbs breaks, all the others will go off too. Okay? Electric wires. We all have electric wires in our houses. They are wrapped in plastic or rubber. From the outside, they are covered with plastic or with rubber. Why is that? Is it because plastic and rubber are good insulators, good conductors, or good magnets? What's your answers?
Green.
Plastic and rubber, are they insulators, conductors, or magnets?
Insulators.
Who is this? Is this Zahra? Good job. Where are the others?
Insulator.
Plastic and rubber are insulators and not conductors or magnets. Lina, please unmute. I'm talking with all of you, miss.
Miss,
Plastic,
can I go to bathroom?
plastic and rubber are insulators of electricity. What do we call the road or the pathway made for an electric current? The place where electricity flows, do we call it a magnetic field or an electric circuit?
An electric circuit.
Electric
Circuit.
for sure. An electric circuit for sure. Electricity can flow through aluminum and human body or copper and wood. So we have aluminum, human body, or copper and wood. Where electricity flows in which choice? In which choices does it flow? In aluminum and human body or in copper and wood?
Copper and wood.
Copper and wood. So do you think that wood is conductor of electricity? Does wood conduct electricity?
Yeah, that's what I'm thinking of because the wood is not a good conductor.
The wood is an insulator. So which choice is the best one?
Aluminum and the human body.
Aluminum and the human body. For this reason, is it allowed to touch or to play with something electric? Are you allowed to, for example, put your hands on something or play with an electric device?
No. No.
Be careful. Using electricity, especially when your hands are wet, especially when you are in the bathroom. Okay, be careful using electric machines. Since electricity is too dangerous and it can flow through your body. If electricity catch you, it will use you as a part, as a wire. It will flow through you. Okay, so you have to be careful using electric machines, especially when your hands are wet, when your body is wet. Please be careful using them. Do not play with any electric machine if you don't know how to use it. Okay? If bulb B is burned, if bulb, we have 3 bulbs connected to each other. Yalla, let's see. Which ones are in series and which ones are in parallel? Electrons flow from the negative side to the battery through bulb C, then bulb B, and back to the battery. C and B belong to the same loop. So C and B are what? Are they connected in series or in parallel?
Series.
Series.
C and B are in series. What about
Series.
C and A?
A and C are in parallel.
Let's see.
Parallel.
Electrons leave the battery. They flow through bulb C, bulb A, and then back to the battery. C and A belong to the same. C and A belong to the same loop. So C and A are what?
Parallel.
Parallel.
C and E are in the same road, same loop.
They're series.
Series.
They are in series too. But look at B and C. B and A, sorry. Look at B and A. How are they connected? B and A are
Parallel.
B and A are in parallel. Yeah, let's see what happens. Bulb B is burned. This one is burned. It's not functioning anymore. Which light bulbs will light up? Bulb B,
No bulb.
bulbs A and C, or no bulb?
Bulb A. Bulb A and C.
Yeah, let's see. Bulb B isn't working anymore, so electrons will leave the battery. They will go through bulb C this way, bulb A, and back to the battery. One loop is working. It's the loop having or containing bulbs A and C. Which bulbs will light up?
A and C.
A and C. Thank you. Yeah, we will start talking now about electromagnets. Let me make this bigger. To create an electromagnet, يعني a magnet that works using the power of electricity, you have to coil the wire as it's shown right here. Coil the wire around an iron nail, and then you have to connect both ends of the wire to the battery. An electric current travels through the wire, and then the nail becomes magnetized. Okay? Look at here. We have 4 different electromagnets. Let's put them from the weakest one to the strongest one. Which one is the weakest electromagnet? They are all working. Okay? All of the electromagnets are working, guys. Which one is the weakest one?
B
B is the weakest one? Who's saying B? Why is that?
No, C, teacher, C. Teacher, C.
Okay. C is the weakest one. Look, it does not have too much coils. And it doesn't have a metallic core. It doesn't have an iron nail. So this one is the weakest one. Then, which one is the second?
A.
The same electromagnet, we add an iron core. So this is 2. Now, electromagnet A is stronger than electromagnet C. Then,
D.
Miss, no, B. Miss B, because in D we have 2
bravo ya Kassab. This is 3. And last one, this is 4. Let me tell you why. Okay? Let me tell you why.
We have 2 batteries in.
That's right, bravo. Electromagnet C, we have a small number of coils and 1 battery. Okay, and there is no iron nail in it. Then we added to the same electromagnet an iron nail. Now it is stronger. It is stronger. Okay? In B, we added too many coils. So let me write it here. How do we increase the power of our electromagnet? Add an iron nail. This is one. We can add an iron nail. How we can add more turns, as it's shown right here. We added more turns to the electromagnet. What is the third way to increase the power of an electromagnet?
Add more batteries.
Add more batteries. Increase the electric current. Yani more batteries. So we have three ways to make our electromagnet stronger. Oh, we add, okay, number one, this one is working, miss, okay? This electromagnet is a good one. It works. It is magnetized and it is acting like a magnet. But it's not too strong. What do we do to make it stronger? We have three choices. Okay? We add an iron nail, we add more turns, or we add a battery. So the answer right here will be from the weakest to the strongest. C, A, B, and last we have D. Yeah. Increase or decrease. Increase or decrease. Increasing the number of coils. Ali Hussein, Ghina Mahfouz, Asim, Mustafa, and Zahra, please unmute. Please unmute. What happens when we increase the number of coils in an electromagnet? Will this increase the power or the strength of our electromagnet? Will it decrease it? When we increase the power of our, when we increase the number of turns, when we add more turns, will this make our electromagnet stronger or weaker?
Stronger.
Stronger. So increase. What happens when we increase the voltage, when we add battery? When we add a battery? Increase the voltage. How? Increase the electric current. What happens? Will this increase the power of electromagnet?
Increase.
Increase, bravo. Thank you, Yahya. Will also increase the power of electromagnet. Did we all get this? Is this clear for everybody?
Yes.
Okay, good.
Yes.
Draw a battery, wire coil, and a magnetic field, يعني an electromagnet. Label the positive and negative ends of the battery. Yalla, what should I draw? Tell me.
Battery.
How do I draw a battery?
And the wire part.
How do I draw a battery?
Line and then one
Big
short.
line. And tall small one. Short one.
Okay.
And the plus and minus.
plus and minus. Thank you. And we have to draw a magnetic field, an electromagnet. And then what do?
I connected them.
I connect.
White coil.
Let's label. This is the positive side, and this is the negative side of the battery. Okay? Clear? Is it clear for all of you? Here is the battery.
Yes.
Here is the battery, the wire coil, and in the electromagnet, we have a magnetic field. What happens if we bring a wooden block, something made of wood, near the coil? Yani right here, I bring something made of wood right here. What happens?
It will went off.
Will the electromagnet attract it?
Nothing will happen. No.
Yes.
Will the electromagnet attract it?
No.
Yes. Yes.
Yes or no?
Yes.
No.
No.
Why?
Yes. Because the wood is not a magnet.
Because wood is not magnetic. Nothing happens. Nothing happens because magnets do not attract wood. Wood is not magnetic. Even if you bring a normal magnet, the normal magnet doesn't attract wood. And also electromagnets do not attract wood. طيب, what happens if you bring a coin, a penny, a coin next to electromagnet? What will happen? What will happen? Will the electromagnet attract it? Yes or no?
Yes.
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 The electromagnet attracts the penny or the coin. Is it clear for all of you? Is it
Yes.
clear for all of you? Electromagnets do not attract wood, but they do attract metals. So the electromagnet will attract the penny. Last question and we are done. Yalla, I want you all to participate. I'm talking with all of you guys. Question number 4. We have 4 electromagnets. Which one of these 4 electromagnets is the strongest? So we have electromagnet A, electromagnet B, electromagnet C, electromagnet D. Which one is the strongest?
D.
D.
Why?
Because it has a lot of like turns on it.
It has more coils, bravo. It has more coils in it.
And there's double battery.
And there is double battery.
Double battery.
Excellent answers, bravo. There are 2 reasons. أول شيء, it has more coils with double batteries. So D is the strongest. Let's put them from the weakest to the strongest. From the weakest to the strongest.
A,
A is
A.
the first one, bravo.
B,
B.
B,
C.
A,
C,
A,
and
D,
D.
D. Bravo.
D.
B, and
Excellent job. أول شيء A عنده a limited number of turns. Then B has more coils, more turns, so it is stronger than A. C عنده 2 batteries. Well, D is the best or is the strongest because it has more coils and double batteries. What are 2 ways to turn off an electromagnet? We said that electromagnets are not permanent. We can turn them off. How can we do this?
We open the wire.
So, number
or we
1.
cut the wires.
Cut wire.
Okay, you're saying 1, cut the wire. What else? What
Hit the
can we-
battery. Like
What?
smash
The
wires.
Teacher, cut the wires.
Destroy the battery?
Yes.
Let's say remove the battery.
Remove the battery.
Remove the battery. We can, for example, disconnect the wire from the battery. What else? If there is a switch, we can turn the switch off, right? So in all of the cases,
Yes.
we have to open the circuit. يعني هون, in all of the cases, we are opening the circuit. When we open the circuit, the electromagnets are off. Okay? Is it clear for everybody? Do we all know now everything about electromagnets? Electromagnets use the power or use the electricity to work as magnets, and then they attract metals. Okay? For sure, they need a complete circuit. They need a closed circuit to work. If the circuit is open, the electromagnet will go off. Okay? Is there any questions about the electromagnet? Sure, guys, any questions about electromagnets?
No.
Okay. Great.
No.
So, thank you for joining me. Have a nice day. You did good today. If you have any questions, you can leave.
Thank you, Miss.
Bye-bye.
Okay, bye, Miss. Have a great day.
To you too.
Bye now.